Right, what have we done just now? Basically, we are just discussing about the three centers. Right, so statistics have center, have dispersion, and also have location. So what we have just discussed just now is on the centers. There are three centers in statistics, and they are called mean, mode. So what is the mean? Is just the way you calculate average from young, right? So there are two formula for this calculation is because we have two groups. One is called the population, one is called the sample. So they are of different groups, so they have different formula. So one that with all the English letters A to Z belongs to the sample. When you see the capital letters or you have a Greek letters in your formula, then that formula will belong to population. Yeah, this overall, this is how you define them. How you calculate average is just use these symbols. Average of a sample is denoted by X bar. Okay, and how you do it is just sum up all the X. You don't need to write this. And you just say, okay, it's 30. Press your calculator, you say it's 30. Then you divide by 10. Right, so that's how you do. Median is a number right in the middle. So if you use a normal way of cancelling on two sides, that will be easier to detect. But if you would like to use a median index, which we use this formula again in quartile, in the location measure, we are going to follow some rules. Okay, so these are the rules. If the I gives you a round number, then you have to take the average of the I and the next I. But if I gives you not a round number, then just round up to the next higher number. Okay, the next one. So you get 8.1, the next one will be 9. Right, this is how you figure out. You get 8.25, there will be 9 also. But if you get 8.75, also 9. Discuss mode as well. Mode is the number that occurs most frequently in your data set. We talk about model class when you already summarize the data in the frequency distribution table. You log original numbers, but you can only know which class gives you the highest frequency. That is called the model class. Right, so what I mentioned just now, that mean and median, what you need to do is you just identify, just to know that one is very sensitive to extreme values. The extreme values in statistical term is called the outliers. The other one is not sensitive to extreme values because it is right in the middle. It will not be affected by huge values or small values in your data set. Okay, now what I'm going to show you is is an important item in this topic. How do you actually use mean and median to find out some other things? Okay, so I'm sure some of you don't feel like drawing the graph that I asked you to draw from last and right. You need to draw histogram, you need to draw polygon, you need to draw ogive. You wish that no need to draw. Okay, this is nothing surprising because I don't think anyone loves to draw graphs. For one set of graph is okay, 2 or 3 sets is still okay, but if every lesson I ask you to draw, probably you say forget about that. Right. So now I'm going to tell you a good news is without drawing the graphs, when you look at your mean and median, you can actually know whether your graph is bell-shaped, which is symmetrical, balanced on both sides, or your graph is skewed to the left or skewed to the right. Okay, so now I'm going to share how you're going to see this concept. This is the graph. This is the data that you used in the previous topic, the weekly expenditures, when we first developed the frequency distribution. Now, if I were to ask you what is the mean and what is the median of this data set, use the way you calculate. So if you want to find the mean will be just adding all the numbers together, divide by, you have 20, right? Okay, divide by 20. So you get 32.4. How you find the median? You just cancel on each side and you find that the median is just right in the middle of 30 and 32. So it's supposed to be 31. So mean is bigger or median is bigger? Mean is bigger. Remember the concept that I shown to you earlier? If you have a bigger number or bigger extreme values in your data set, the mean tends to be bigger. So if you have a mean which is higher than, that means there are big numbers, there are more big numbers in your data set compared to the small numbers. So you have, in a way, your graph is not balanced. You will have a longer side on the right hand side, which is on the bigger number side. Okay, you should look at this. Means your mean is slightly bigger than median. Now I'll show you the graph of this. Okay, the graph of this. We plot it into a frequency distribution, and this is the frequency we get. This is from last lesson. Okay, so I'll use this and draw it into a histogram. This is the class 10, 20, 30. That it will be the frequency. So after getting all this, you put out the frequency 3, 6, 5, 4, 2. Okay. Now you look at the shape of this graph. What is this shape? Is it symmetrical? Not balanced, right? Which side is longer? Seems that the right hand side is longer. Okay. So you have a longer side on the right hand side. If I were to draw this, okay, let me draw something on it. Use another color. Where is your, I think I just use this screen easier. 32.4 is the mean. So where is the mean? 32.4. So if I were to draw the mean here, it will be 32.4. Let's say I draw a line here. Okay, that is mean 32.4. Okay, then I draw another line. That line is probably, okay, that will give me median. Okay, median is 31. So 31 is on the left hand side of 32. So I just draw a longer one, and this is median. 31. So what do you notice here? You see that the mean is bigger than the median. Yeah. The mean is bigger than the median. It's illustrated here. The mean is on the right hand side, which is a number on the x-axis compared to the median. So if you have such thing happening, then you expect a graph which has a longer side on the right hand side. Mean is bigger. Mean is bigger. Okay, you have a right skewed graph. So same, you see that you have a right skewed graph. The graph skewed to the right hand side. All right, so just draw it. You see that? Right. So now you don't need to always draw the graph to see the shape of the graph. What you need to do is you just need to calculate two numbers. One is a mean, one is a median. If they are equal, then you should have a balanced graph, which is symmetric, or you call that bell shape. If not, they will be slanted on one side. Which side it slants, follow the mean. If mean is on the bigger side towards the right hand side, then it's called right skew. If mean is on the left hand side, then it's called left skew. Okay, So by looking at two numbers, you can know whether the graph is skewed or not skewed. It saves the trouble of us drawing graphs. Okay, that is a very first step that you can actually make use of. Clear? Right. Right. That's all about mean, median, mode, which are the centers. Now let's look at other things, which we call that quartiles. Quartiles in English, quarter means 1/4, right? So quar means you split something into 4 sections. So when you arrange your data values, arrange them from the smallest number, minimum, all the way up to the maximum number. So from the smallest to the maximum, and you split it into half. Remember just now you split it into half and find the one right in the middle. That is called the median. Okay, so median is on the 50% point. 25, 25, 25 plus 25 will give you 50%. Now you're going to split up another 2 on the lower half and another 2 on the upper half. So you split up another 2 here, you split into 2 and split another 2. So each action will be 25%. So at this point, you call that median. At this point, you call that first quartile, the first of the 4. This will be the second. This will be the second of the 4, second quartile. This will be the third of the 4. Okay, at this point. So this is called the first quartile or lower quartile. That's called the third quartile or upper quartile. So the second quartile or the median, there's another name called middle quartile. Right. So in statistics, usually we just use symbols. This is just a short form, not really a symbol. Q1, Q stands for quartile, 1 stands for the first, second, and third. Right. So you see that first quartile is at the 25th percent point. We also call that 25th percentile. And this one will be on the 50th percent point. It's called 50th percentile. So it's 75th percentile. Right. Now, how do you calculate the quartiles? You're going to use the I formula again. Yeah, this I formula. Now, remember the P in this I formula looks a little bit different from the median, right? Not really so. For first quartile, Q1, it is at the 25th percent. So you put P equals to 25%. Right. So when for Q1, I will be 25 over 100. And for Q2, which is a median, which you calculate just now, is actually based on this formula. It will be 50th percentile, half. Or simply half. This is the one that you saw just now. So the actual formula is in percentile, which is 50 over 100, 50th percentile. And you have another one, which is Q3, will be I equals to 75% at the 75th percentile. Okay, right. That's how you find it. Now the rules are same. Now let's look at this data set. You have 19 numbers altogether, right? So if you want to find first quartile, third quartile, you just need to use this formula. First quartile is 25th percentile, so this is Q1. This is Q3. Then you find 25 here, and this is 75 here. Then you get this. Is it a round number? Of course not. So if it's not a round number, what you do? You just round up to the next round number. The next round number will be 5. So that will be the first quartile position. The 5th number is the first quartile. So the first quartile is 51. Same for the second one, 14.25, round up to 15. So it is a 15th position. So this is number 1, this is number 2, so this is number 5. Okay, so this will be the 15. right? So how about if you have this number, which is end up with a round number, what do? A round number means you have to get two numbers, the fourth and next one. Then you get the average. Same for this. 12 means 12 and 13. Then you get the average. Right? So this is how you find quartiles. So we are done with the first section. Let us go to the second section. So this is how I ask you. If you have two sets of numbers, and these two sets of numbers are giving you the same average, does it mean they are identical? They are exactly the same? Not really. Right. So what is the difference? Is the dispersion, how spread out they are. Variation means how spread out they are. Right. So if you look at a set of numbers, one is in this from 1 all the way to 20, and you find the average is 11, for example. Okay, 11. Yeah, the average is 11. But you have another set of data which range from 6 up to let's say 15 only. The average also 11. What do they have in common? They have the same average. Why makes them different? What differentiate them is one, there's a wide spread of number from 1 to 20. The other one is from 6 to 15, so a smaller spread. Right? So this is the spread, or we call that variation. If you have a set of data that have variation, then that means not all the data values are the same. There will be some different numbers, yeah, 1 to 20. The average is 11. So variability, how do you interpret it? The smaller value, less spread. Larger value, more spread. Okay. In terms of drawing is, if you have less spread, that means they spread out very little. Your histogram is very compact. But if you have a widespread histogram, you see the x-axis is very wide. Okay. So this is all the spread. We have all these are spread. Yeah, we're going to look at them one by one. Now range, you already know what to do. What is range? You knew range when you work out the histogram. Frequency distribution. The smallest number and the biggest number. What's the difference between them? That is called the range. Okay. Now you have something called interquartile range as well. Then the next category is a variance, and the next category is standard deviation. Okay. Now later I'm going to show you that these two are very closely related. Right. So let's look at this. If you have a variance which is 25, what will be the standard deviation? What will be the standard deviation? The standard deviation, you don't need to recalculate everything or use another formula to calculate. You just need to square root the 25. How much is it? It's just 5. So if the variance is 9, and how much is the standard deviation? With the square root of 9, that gives you 3. Right, so that's how they are related. The other way around, if I give you the standard deviation, I will give you standard deviation is 4. How much is the variance? 4 times 4 equals to 16. If the standard deviation is 6, then the variance will be 6 times 6 equals to 36. So you find one of this, you find one of this, you can find the other one very easily. Yeah, at the bottom, you still have two groups because one is for the population, one is for the sample. In the exam, you focus on the sample formula. Okay, focus on the sample formula because most of the time we don't have population data. But just to introduce to you what are the symbols we use in population formula. Range is the one I show you, the maximum value of a data set minus of the minimum value and give you the range. Okay, that's simplest of all, but it's not really useful if you have extreme values. Yeah? So for example, your highest value is very big, then you end up with a range which is very huge, but it's not really true. It's just because of one number that makes the range is very big. Now, how do we get rid of this problem? We are going to consider something called interquartile range. It is also a range, but this range is only concerning the Q3 and the Q1. That range is called interquartile range. When we arrange our data from the minimum to the maximum, the extreme values or outliers will always be either this end, the very small number, or very big number, right? It will never be in the middle here. Okay, so if you just use the middle here to calculate the range, then this range will consist of 50% of the data set. Yeah, the 50% range. That will be good enough for you to know something. Yeah, so interquartile range, the R short form IQRs then come from here, interquartile range. It's just a short form for interquartile range. We have found the quartiles in the previous example. Right, so for this example, the quartile is 88 and 51. So finding interquartile range is very simple. You just take 88 minus 51. That will give you the interquartile range, 37. Right, so now let's look at variance and standard deviation. Just need to get use of some of these symbols. You knew this earlier. What is the meaning? It's the population average, right? How is it right? You read it as mu, right? So for variance, it is this symbol square. Yeah, remember, this symbol is just standard deviation. You square it, you get variance. So this symbol is called another Greek letter. This symbol is called sigma. All right. So how do you calculate this? Don't just ignore this formula for a while. I'll explain that. Since we always don't have population data, we have to focus on the sample data to do a calculation. So when you do a sample calculation, you notice that there are some slight changes here. The sigma is denoted by S now. So sample standard deviation is symbolized by S. Just now you saw X bar. X bar is just sample mean, right? So S will be the sample standard deviation. Okay, so be the sample standard deviation. If you square it, it becomes a variance. Right. So what else is different? This is divided by n, and this is divided by n minus 1. So this is theoretical formula. This formula will explain to you what does it mean by variance or standard deviation. But this theoretical formula, when you do a calculation by hand, it can be quite tedious. So when you do calculation for this particular module, you use a shortcut formula. Now you ask me, this shortcut formula looks more complicated than this. Not really so. It looks complicated, but when you start calculating it, it is simpler. Now before we go into this shortcut formula, I will show you what is the meaning of variance and standard deviation. Yeah. I do not want you to study the standard deviation and variance, but you don't know what is it. Yeah. So now I'm going to show you what does it mean. This is all about the shortcut formula. It's used for calculation by hand. Look at this. I'll bring this over first. I need the space to draw something. Okay, now I'm going to draw something here. You have a list of numbers. This is a list of numbers that's shown in mean. Yeah, when we start calculating the mean, this is a 10 numbers. And these 10 numbers give you an average of x bar equals to 3. So now I'm going to do illustration to you to explain to you what is standard deviation. Right, first of all, I'm going to maybe I draw it lower. Okay, how many numbers we have? From 0 up to 7. So this is 0, 1, 2, 3, 4, 5, 6, 7. Okay, and what is a mean? Mean is 3. So I'm going to draw a line here. Show that this is 3. This is mean. I'm going to measure how far are all other numbers from 3. Okay, how far are all these numbers from 3? So the first number is 4. First number is here. How far is it from 3? It is 1 step on the right of 3. How far is 7 from 3? It is 1, 2, 3, 4 steps to the right of 3. Then how about 1? 1 is here. How far is 1 from 3? It is 2 steps to the left. How far is 0? It will be 3 steps to the left. How far is 5? 5 is 2 steps to the right. Okay, where are we? 1, 2, 3, 4, 5. 0. Another 0 here. Left, 3 steps to the left. 3. Okay, the next number is 3. 3 is where? Where is this exactly on the mean side? So you just draw it here. No distance. Next, 2. 2, how far is it from 3? 1 step to the left. 6, how far is it from 3? 3 steps to the right. 2, again here, 1 step to the left. Okay, now you take your calculator or do a mental calculation. Add this number up. This. See all the difference, the distance from 3, right? This. What did you get? You get a 0, did you? 0 means there's no distance from 3. But you know very well there's only one number which is 3. Another 9 numbers are not 3. So it cannot be no distance, correct? So there's something wrong with it. Now, the problem is there are some negative, some positive, there, each one counter each other and you get nothing. So what are we going to do is we're going to make sure everyone has the same sign. So we are going to make the negative into a positive. How to make negative number into positive? You can square. Okay, square this. Square all these numbers. And at the same time, you square this as well. Positive square, you still get positive, no problem. But now the negative become positive, so everything will be squared. So after you square everything, you add them together. How much you get? You should get 54. Now this 54 come from all the 10 numbers, right? Even though there's one which is 0, you count it as 10 numbers, okay? 10 numbers. Now according to the formula, there's n minus 1, so minus 1. So in concept wise, it's like finding the average. Yeah, you are looking for the average. So the standard deviation, the variance itself, the variance is average of squared distance from mean. Okay, this is something very simple logic. It's just the average of squared distance from mean. But the original data is not squared, right? And we square it, something doesn't look the same anymore. So that's why we have to square root. When we square root variance, we get standard deviation. So when you find the standard deviation, it will be just the average distance from mean. Squared, no more already because you square root. So what is standard deviation? A standard deviation measures the average distance of all the numbers from the mean. Calculation is easy, but what does it mean? Yeah, so when you see a standard deviation, or when you calculate the standard deviation, if you know what does it mean, then you can actually know whether your number that you have calculated makes sense or not. So standard deviation means the average distance for all the numbers here from the mean. So how far, on average, how far is every number from the mean? The distance is around 2.449. This is about 2.4. Right, so we can say that all these numbers, on average, this data set, the value are about 2.4 steps away from mean. Okay, so this is how you explain standard deviation. Right, so of course you see that the process we do it, right, is quite tedious. You find the difference, then you square it, then you add that. Right, so we are going to use another formula. This is another formula. So what you do is you just follow what the formula says. You know the n, right? There are 10 numbers, so the n is 10. So this is 10, this is 10, this is 10, no problem. You know this also. What does it mean? It means add all the data set, add all the data values. So you add, like what you have done for the mean. How about this? This is a little bit tricky. It looks the same, just that there is a bracket and the square is outside. This one no bracket and the square is inside. Yeah, means you go to square first before you add. This one you add first, then you square. This is you square first, then you add. Okay, so these two numbers cannot be the same. Yeah, remember. So you calculate, you just press your calculator straight away and you get 144. Okay, and that one is 30. Then the rest is just pressing the calculator. So this is called the variance. This is the variance, and this is the standard deviation. This is S squared. Variance is S squared. Standard deviation is just square root of S. Clear? Right. So we're also done with the second section about the standard deviation, the spread. So now we just combine these two information and let you see in diagram form how do you actually define the set of data, which one has a higher spread, which one has the lowest spread. Now, all these three data set, what is the number? It goes this way. The data set A has 11, 12, 13. Then you have two sets of 16. That means you have 16 and 16. Okay, you have 16, 16, you have 17, you have 18, and you have 21. So these are all the value in this data. You find that the mean is 15.5. This data set, you have 14, you have three numbers of 15, you have three numbers of 16, and you have one number of 17. You also get the mean, which is 15.5. Same for this. You have three sets of 11 and 12, then 19, then you have 20, 20, 20. You also get 15.5. Then you see that you get the same mean. That's what I asked you at the very beginning, right? You have the same mean. But what do they difference? They are totally different numbers. Most of them, they spread out differently, right? So which one spread out more? I would say this one spread out the most. Yeah, so all the numbers are mostly at the end. Compare that this one is totally at the middle. This one has the lowest spread. This one is in the middle of that too. Okay, so this has a higher spread. You have the higher S standard deviation. This has a lower spread among the three, and this is in the middle of these two. Okay, so we have the center, we have the spread, and we're going to make these two come together, right? So how do we make these two come together? Remember this shape? Now this shape come from a bell shape that you see in earlier in a topic, and also this topic in the middle, right? So this is called a symmetric or bell shape. And this rule only applicable for bell shape. If the shape is not bell shape, then this rule doesn't apply, remember. Now, how does it work? Is if you have a bell shape, remember in the earlier section, in the earlier slides, you know that this is the mean. This is the mean, right? This is the mean. So for any bell shape, you can actually cut three sections on the right hand side. 1, 2, 3, 1, 2, 3. Okay, and each of these sections is one standard deviation. Right, same for the left hand side. So are you well versed with this already? What is this? This is mu. Mu is just a population average. And what is a sigma? Sigma is a population standard deviation. So I can use a sigma to define this. This is one sigma, this is another sigma, this is another sigma. Okay, so same for the left hand side. So one mean and one standard deviation. Plus and minus means you plus one standard deviation, you minus one standard deviation. So one side you plus, one side you minus. That means the area covered will be this area. Okay, so how many percent is this area compared to the entire area below this curve? According to Ray's rule, it says 68. So the green shaded area here is 68% of the entire curve. Then you can also extend to two standard deviation. So 1, 2 from here, and 1, 2 from here. So from here all the way to here. So it's a bigger portion now. This portion, how many percent? 95%. So you have another three section. 1, 2, 3. 1, 2, 3. How many percent? 99.7%. So how many left on two sides? So how many more left here? 0.3% divided by 2, right? This side, 0.3% divided by 2. Why 0.3%? 99.7%. 100% take away 99.7, you only left with 0.3. And this 0.3% is shared on two sides. So one side is only 0.3%. 15%. So very small. So we don't bother to write another section. So we are more interested in the first three section. 1, 2, 3 on the right hand side, 1, 2, 3 on the left hand side. Yeah. Now these three numbers you have to remember. This is a magic number. 68, 95, 99.7. 68, 95, 99.7. Later, topic 5, you will see how you get these numbers. At this moment, you just remember it's 68, 95, and 99.7. Okay? Right. So just example to show you further. If you have a mean which is 50, you have a standard deviation which is 10, then the number right in the middle should be 50. Then what's the number next to this? If this is 50, then what is this number? Standard deviation, one standard deviation is 10. According to here, 10. So 50 plus 10 will give you a 60. Okay, so you get something like this. 50 plus 10 plus 10 plus 10. This one 15 minus 10 minus 10 minus 10. Right. So this percentage will also say there are 68% of the data points which falls between 40 and 60. There are 68% of the data points falls between 40 to 60. Or another way is, if you were to pick up any number randomly from this data set, you have 68% chance of getting a number which is between 40 to 60. I repeat, if you were to pick up a number from this data point, this data, then you have 60% chance that you will pick up a number which is between 40 to 60 because it says so. Then you have 95% chance of getting a number which is between 30 to 70. Right, so this is empirical rule. Right, so that's all for this topic. Now, in order to make sure you know how to do it and what to apply, we are going to look at one exercise here. And this exercise includes everything that you need to know in this topic. Yeah, so if you know how to do this exercise, you get it. You got your paper and pen ready? You need to write something. The waiting time of a random sample of 6 customers are as below. 1, 2, 3, 4, 5, 6 numbers. They are all waiting times, okay, in minutes. Find the mean, median, mode of the data. Find the range, variance, standard deviation of the data. Find the interquartile range of the data. Okay, so I'm going to show you on paper. You also write on your paper, right? Mean. How do you calculate mean? You have some guidelines here, okay? This is the first topic where it appears in the formula sheet. Yeah, mean is just x bar, standard deviation is s, and you have the percentile I, the I index here. So mean is this. So we just copy this formula first. X bar equals to summation x divided by n. X bar equals to summation of x divided by n. So you just press your calculator, add up all the numbers here. All the 6 numbers, can you add up? Then you're going to divide by 6. How much you get? You get 93. So 93 divided by 6, how much you get? think 15.5. That's all you need to know for mean. Median, if you were to use the first easier method, you have to just cancel until you find the center, right? But no matter which method you use, you still have to start off with the smallest number. Okay, so can you write the number in sequential order from the smallest to the highest? Okay, from the smallest to the highest, then you find out the middle, right? So the easier method is the one that we cancel. So this one, you cancel 1. Now you cancel 2. Oops, there's only 2 left. So what is the median? The median is just here. The average of 2, to be fair, is the center of these two numbers. Right, so now I show you the second method, or you use a formula I equals to half n, or 50 or over 100 n, it's the same, yeah? So I equals to half n. How much is it? Why so n? You have only 6 numbers, so you get 3. You get a round number. When you get a round number, what should you do? The median will be the third number, add the fourth number, the third and the next one, right? So what is the third number? This is number 1, number 2, number 3, 4, 5, 6. So the third number is 13 and the fourth number is 15. So you divide by 2, you should get the same answer. Next, what's the question? We got the mean, we got the median. Now we're going to calculate the mode. Okay, so where is mode? Okay, what is the mode? Do you see any number appear more than once? 10, 12, 13, 15, 18, 25. So everyone actually appear only one time, right? So that means there is no more. Is it okay if I write 0? Because in mathematics, usually you say no, nothing, then you write a 0 there, right? Can I write a 0 for the answer for the mode? What is mode? Mode means the number, the data values which appear most in your data set. So if you write a 0, then I expect to see a lot of zeros. The 0 are is the number which appear most in your data. But we don't even have 1 0, right? So never write 0 when you answer mode. You can write mode equals to no mode, or you put none, or you put now there is no mode, as all number appear only once. Yeah, so it's just a very simple one. If there's no mode, please don't write any number. So that is mean, median, and mode. Now we're going to proceed to range. Second question, which is this, the range. Then you have variance, you have standard deviation, yeah. How to calculate range? You take the maximum, the highest number, take away the minimum number, or you put the highest, take away the lowest, or you just write exactly what's the highest here, 25. Take away the lowest, 10. So the answer is just 15. Very simple. What's next? Standard deviation. Okay, which one comes first? You have variance and standard deviation. And if you see your formula, the standard deviation is the one given to you here, but the formula doesn't give you a variance formula. So where is the variance? But you have to know that the variance is just a square of this, yeah? So when you square this, that means this becomes s square, and the square root disappear. So s square equals to the one inside. This is a formula. What's the n? There's 6 numbers, so n is 6. So you have 6, 6 minus 1. Then you don't know what is this yet, but you do know this. Know this from here. You sum out all the x, it gives 93. So this is 93. 93 square. The next is, how much is this one? I'm going to find out. How much is this? You can use a calculator to find out, yeah? How much is this? It's just, you need to square every single number, right? So what do you have? You can use the sorted one from the smallest to the highest, or you can use the original also can, no problem. Yeah, so 13 plus 13 square, 13, 15 square, 13 square up to 18 square. Okay, so just square everything. You just directly press a calculator, square them. Then you add. This is what you actually press. You press 15, then you square. You press 13, then you square. How much you get? You get this? Then you're going to throw that inside here. The rest, just press the calculator. Then you get 29.1. Okay, so that is variance. There is a square here, so it's variance. When you want to find standard deviation, S will be just the square root of the variance. You square root this number and you get 5.4. That's what you need to know when you do this calculation. Let's see what's question. So we are done with the range, variance, standard deviation. Now next is interquartile range. So in order to find the interquartile range, we need to find the quartiles first. So what are the quartiles? C. We're going to find quartiles. Let me copy this again. 10, 12, 13. 10, 12, 13, 15, 18, 25, right? 15, 18, 25. Okay, right. So we're going to use this to calculate the quartiles. How to calculate the first quartile Q1? You use the I formula. The I formula goes P over 100 N, which is here. You can refer to your notes or you can refer to this. Yeah, P over 100 N. So the P is a percentile. For Q1, it is as a 25th percentile, right? The 25th mark there. 25th percentile times 6 numbers, and you get 1.5 as your answer. So 1.5 is not a round number. What are you going to do? You're going to round up to the second data value. This is 1, 2, 3, 4, 5, 6. Okay, second data values. So what is the second data values? The second data value is Q1 will be just 12. Second position is 12. Then you have a Q3 here. The I will be still the same, P over 100, and same formula used for all. There will be 75 over 100. Then you times 6. Okay, then you get 4.5. Not a round number, what should you do? Round to the next round number, fifth number. What's the fifth number? Q3 is 18. Then the question is not asking us to find Q1 or Q3, right? Question is asking us to find IQR, which is the interquartile range, equals to Q3 minus Q1. Now the 3 and 1 can be small or large. It doesn't matter, right? It's just a symbol, right? It's a just general symbol. Then this is 18. And that is 12. That will give you a 6. Did you get all? So these are all the calculation or the measurements that we discuss in this topic. They are all called descriptive statistics. Why? Because they help you to describe your data, describe your sample. So you see that the sequence of this measurement is also makes sense that you have to know the center first. Then you look out for the spread. Okay, so you always start from the center, which is either mean or mode or median. Then you go forward to the spread. Then you have a range. You have the interquartile range. Then you go to various standard deviation according to what you want. Any question up to here? No, I go back here. So this is a requirement for this topic. What you need to know how to calculate. Yep. Okay, next, you have a random sample of 20 pizza delivery times for online orders. So they are all in minutes, 5 to 9 minutes, 10 to 40 minutes, and so forth. So if they have a 20 pizza delivery, 2 of the pizza will be delivered between 5 to 9 minutes. 2 will be delivered between 25 to 29 minutes. Okay, right. So this is just a rough guide that we are not so particular about 9.1, 9.2, or a 9.8 or whatever. So we just put it in this way, right? What is the model class? How do you define model class? The model class is a class with the highest frequency. So which class has the highest frequency? The frequency is highest at this. So which class is it? So which is a model class? The model class will be the class with 15 to 19 minutes. Yeah, the answer is this. You don't need to do any calculation as I shown you earlier. No calculation needed. You just need to identify which is the model class. Got it? Okay. So now you go back to the very beginning. This. You know how to compute the mean, the median, the mode, and understand what these values represent. And you know how to compute the range, interquartile range, variance, and standard deviation, and know what does that mean. And you understand the empirical rule. What are the three values in the empirical rule? 68, 95, and 99.7. Right? So that's all you need to know about this topic. Right. So now can you have a look at your tutorial questions? We discussed topic 1 questions, some of them, and I noted that the rest of topic 1 question that we have not discussed, we will discuss that during our tutorial. Okay, so you get ready for your tutorial. The next lesson, then after that, then we have a one tutorial for topic 1 to 3. Yep, so you get ready for that tutorial, all your workings for topic 1. Now topic 2, you have 4 questions only. Question 1, you have 6 numbers. You are asked to find out the 3 measures of center. So what are the centers that we discussed? Mean, median, mode. What are the measures of variation we discussed? Range, variance, and deviation. And what is the interquartile range? It's exactly what we discussed just now, right? Okay, so you don't need to wait for us to discuss in the class. For calculation questions like that, I will have final answer listed below. Okay, questions like what is the data type for number of classes? That one, you only have one answer, which is the data type is qualitative or quantitative. Those questions we will discuss in the class. Okay, because if I were to give you all the answers, then the answers is whatever I've given you is all the answers. There's no way you can actually, you don't have the opportunity to try, right? So those questions I will not give you answers, but questions like that you need to do some calculation, then only you get the final answer, I will give you the final answer. Yeah, it will be same throughout all the tutorial questions. So this is the one that you have all the answers. A 1 2 3, B 1 2 3, C you need to know quartile 1, first quartile, third quartile in order to get the interquartile range. Yeah, right? So I just list down Q1 and Q3 as well for you. So this is question 1. Question 2, you have 8 numbers, do the same. Question 3, you have 12 numbers, do the same. Okay, now I want to ask you this question. Based on the empirical rule, we can expect about how many percent of the values in bell-shaped distribution to be within plus minus 1 standard deviation of the mean. 1 standard deviation of the mean. How many? Okay, you keep your answer. Now I'm going to ask you. You just write that down, right? So I'm going to ask you. I'm going to start sharing my screen now.